Hello once again. In this chapter we're going to be taking what we have learned about memory and use it in a practical way. We'll have a real-world scenario project which has a memory leak, and we'll use the tools that we've seen to find the source of the leak and fix it. The project that we'll look at is going to be a website running Tomcat. We'll also then learn how to load test the application using a tool called JMeter. This will allow us to see how our application's memory usage performs under stress when there's lots of users all trying to use the application at the same time. So let's get started. The application that I've chosen to look at for this example is a reasonably simple web application that uses the Tomcat web server. Don't worry if you've not done any Java web development before, because you'll still be able to follow along. Let's start by loading up the project. In the starting workspace for this chapter, you'll find two folders that we need this time, called Student Manager and Tomcat. So copy both of these folders to your workspace. So here's my workspace. I'm using the Java Advanced folder as the workspace, and I've copied Student Manager and Tomcat into this area. So the first thing we need to do is to start the Tomcat application. Tomcat, if you've not used it before, is a web server that runs Java. And to start this, go into the Tomcat folder and navigate to the bin folder, and you're looking for the file called startup. Now on a Windows computer like me, you can just click this startup.bat file. If you're using Linux or a Mac, navigate to this folder and issue the command .space and then another dot, a / and startup.sh. Before we run this, I should just point out that the startup of Tomcat uses the setenv file to configure any of the runtime arguments for the Java virtual machine. Now, the format of these files are slightly different. There's a Windows format and a Mac or Linux format, but the content does the same sort of thing. If we look at the Windows version, I'm just going to open this. We'll see it has the XMX and XMS parameters set, so we're setting the maximum heap size and the startup heap size both to be 64 megabytes. That's quite a small amount of memory, and we're doing that so that we can see any memory leaks. On a production server, you'd change these to obviously some much higher numbers. So let's start Tomcat up now. And that's running, so we'll leave that running in the background, and we can now load up our Student Manager project in Eclipse. So in Eclipse, we'll do this in the normal way, create a new project, and just give it the same name as the folder in the workspace, which was Student Manager. And we'll click on Finish to load the project up. Now, this project was taken from the Hibernate course. There's quite a bit in here, although we won't be looking at most of it. I think the things that are worth pointing out are we're going to be interacting with web pages that are generated by the files in the controllers package, and you'll see there's two of those called Add New Tutor and Manage Tutors. And eventually they're going to delegate to the file in the DAO package, which is going to simulate the database. Now, if we look at this file, what we'll see is that when we call get all tutors, it's going to return two tutors to us called Chip and Hank. And if we look at save, when we try and add a tutor, we're going to see that absolutely nothing is going to happen. Now, for the purposes of what we want to do, that's fine. I just wanted to point this out because when we get to actually interact with this application with the web page, if you create a new tutor, you'll notice it's not going to be saved. There's actually no database at the back here. We're really working with a fixed set of just two tutors. So in order to run this Student Manager application, we need to deploy it to Tomcat. To do that, all you need to do is right-click on this build.xml file. Now, because of the size of my screen, I'm just going to make my window a lot shorter and have this at the top so that when I right-click, you can see at least enough of the menu to see what I'm clicking on. And we're then going to click on Run As and select and build. So we'll do that, and that's going to deploy this application to Tomcat. I'll just make that window bigger so we can see in the console window we've got a build complete and build successful message. To interact with this application then, you need to go to this web page that's on screen here. That is localhost:8080/mywebapp/displayalltutors.html. The URL is case sensitive, so mywebapp should all be in lowercase, and displayalltutors has a capital A and a capital T in it. Hopefully you're following along and you've got this web page up. If you have, then you've got everything working. So let's just see what happens if we try and add a tutor by clicking on this link at the bottom here, and we'll put a name in. Let's go for Matt, and I think he should earn, well, lots of money. Let's put in 50,000. I think I've actually put 500,000 in there, but that's okay because as we saw, this isn't going to be saved. We'll click the Add the Tutor button and it tells us a new tutor was added and they have some kind of unique ID. If I click on Display All Tutors, well, if this was a production system, I'd expect to see myself there as well. So let's see how this application is performing using the VisualVM tool. So we're going to connect to Tomcat. We'll just open that. And we'll go straight to the Visual GC. And what we can see that's happening here is that even though we're not doing anything right now, the Eden space is growing. So something is happening in our application which is creating objects, and I hope we'll see in a moment that they're going to be garbage collected. There will be relatively frequent garbage collections due to the small size of the heap. There we are, we just saw a garbage collection happen, and there's very little in the survivor space. So that tells us, I think, that everything is fine. There are lots of objects, but most of them are not surviving a generation, and we can see that the old generation is at a reasonable level. If I left this running for a few hours, I'd expect the old generation not to grow very much. Tomcat is not known for leaking, so if there was a problem here, it's likely to be in our code. I can't tell by looking at this whether or not there is right now, because of course our application is just sitting there not doing anything. Let's do a manual garbage collection just to see what that does to the old generation. So to do that, we'll go to the Monitor tab and click on Perform GC. And we'll go back now to Visual GC, and we can see that the old generation has shrunk. We've got a graph of the size of the old generation over time here, and we can see it has gone down a little bit. So I think, again, that looks reasonably okay. But I want us to imagine that we've had a report that after 2 weeks of our application being used on a production server, it fell over. It ran out of memory. So that's going to be quite tricky for us to try and identify what caused that. I think what we need to do is to load test it, to simulate lots of users or using the application so that we can understand what happens when it is in a production environment. So we'll use another tool to do that load test for us to simulate lots of users, and the tool we're going to use is called JMeter. This is quite an old tool, but it's reasonably nice, it's widely used, and it's free. And I've provided a copy of the JMeter files in the starting workspace for this chapter. So in the starting workspace, it's in the folder called Apache JMeter. And to start this, just go into the bin folder, and there is a jar file here called Apache JMeter, and we want to run the jar file. Now, if you're on Windows like me, you can just double click the jar file and that will open it in Java. If you're using Linux or a Mac, you'll need to run it from the command line by navigating to the folder and using the command java-jar and then of course the name of the jar file. Now, using JMeter isn't completely straightforward, so follow along with me and we'll see how to configure it to simulate lots of users all using my application at the same time. So the first thing we want to do is to create a thread group. So we're going to right click on the test plan and click on Add and Threads and then Thread Group. For now, we'll just leave this as one thread. We're just going to simulate one user, and then we'll come back and change this later to simulate lots of users. So one thread is fine. We'll now right-click on the thread group, and we want to add a configuration element. So we'll go into add config element, and the type of config element we need is an HTTP cookie manager. This is needed to avoid thousands and thousands of sessions being created, which will give us a different type of problem that we're not trying to track. So we'll select the cookie manager, and I don't think we need to change anything in here. We can just leave that there, and we'll just right click on thread group one more time. And this time we want to add a sampler, and it's an HTTP request sampler that we need. So we're going to be trying lots of HTTP requests. That's the idea. So in here, we want to change a few things. The first, I'm just going to make this window a little bit bigger, is the HTTP request, the request to our web server. We wanted to use the post method because the form that the users are filling out on the add new tutor page, let me just show you that page. If we click on Add New Tutor, if I right click here and view the page source, we'll see that the form is using the post method. So we're trying to simulate people filling in this form, so we'll change our method here to post. We need to provide the path. Well, again, looking at the source for the web page, the path that our form is pointing to is mywebapp/addnewtutor.html. So in fact, I'll copy that and paste it in here, but we need to provide the full path. So that's going to be http://localhost:8080 and then /mywebapp/addnewtutor.html. When the form is submitted, we're going to be providing two parameters, which are a name and a salary. There are two HTML input elements here, and they are named name and salary. So we need to include those as parameters in our sample. So in this parameter section here, we're going to add two of them. So we can click on the add button twice. The first one has a name of name, and we need to give it a value. It can be absolutely anything. I think we'll put Matt in here. And the second one has a name of salary. And again, we can put anything in. I think we'll put in 50,000. So what we've set up here is a test plan with one user, because there was one thread in the group, that's going to be adding an individual tutor with these parameters. Now, in order to see what's going on, the other thing we should add is what's called a listener. So again, right click on test plan, and this time we're adding a listener, and we want to view the results in a table. So that will allow us to see, as our simulation happens, as our load test runs, what's happening. So let's run the load test. We do that by clicking on this green arrow button here. We'll click on Start. Okay, yes, we'll save it first and call it anything you like and just save it. And that's now running, and we can see that our one user completed okay. We've got a green tick in the status. If we look at the visual VM that's still running in the background, there's nothing obviously worrying happening there. In fact, it's almost undetectable that we ran creating a new user. So let's now actually load test it. Let's run with 200 concurrent requests to add users. So we'll go to the thread group page and we'll change the number of threads from 1 to 200. And not just are we going to have 200 users, but we want them to keep looping forever and ever. We want them to be constantly hitting our web server, adding more tutors. So we'll also tick this forever box under the loop count. Again, let's run this now. We'll click on the green play button and just go to the view results in table. We can see all our users being added there. That all looks okay. Let's go and look at the visual VM. And well, we can now see that our old space has grown massively. Look at the jump up here in the history table, and each time there's a garbage collection, and notice that the garbage collector is working very hard now. We've got a solid green bar in the garbage collection tab. But when we are having garbage collections, well, not much memory is freed up. So we can see there's definitely something wrong here. Let's force a full collection just in case that makes a change. We'll go to the Monitor tab, click on Perform GC, back to Visual GC, And in fact, no, there's no obvious difference. So we can see that the garbage collector is doing full garbage collections on the old generation to try and get some space. It's not managing it. So how do we work out what's wrong here? Well, I think the first thing to do is to get a heap dump and to analyze it in our analyzer tool. So we'll do that on the monitor tab. Let's click on heap dump. That will create one for us and it'll tell us in a moment where it saved it. Okay, so we've got the location of where that heap dump file is. I'm just going to copy that. And in fact, I could stop my simulation running now. So let's go back into the JMeter application and we'll click on stop to stop the simulation. Now we want to run our memory analyzer tool, so we'll do that. So here's our memory analyzer tool that we saw earlier in the course. I'm just going to close the welcome window and we'll open the heap dump file that was just created. So I'm pasting that in here and clicking on open. And we'll give this a moment to analyze the heap dump. Okay, well, we've only used this tool once before. You might remember when we looked at it previously, there was one problem suspect. Now we have 3 problem suspects. So what this is telling us is that the total size of our heap was 40 megabytes. That's the total size of the old generation. If you remember, when we ran the application, we ran it with a heap size of 64 megabytes. So Java decided to allocate 40 to the old generation and the other 24 to the young generation. Our old generation has filled up, and we can see that of that 40 megabytes, half of it is being used by 3 objects. One at 8 megabytes, that's labeled A, one at 6.8 labeled B, and one at 4 that's labeled C. So let's look further down this report to find out what these objects are. We'll start with the biggest one, with object A. So we'll just click on this details to get the tree of the objects, and we need to start at the bottom of this tree and work upwards. Now, I should probably say that because we're using Tomcat here, there's quite a lot of classes here that are really the Tomcat classes, but we're not really interested in those. What we want to do is look at, up this list from the bottom, where does the amount of memory suddenly get big? Well, we can see it's on this line here, which is the web app class loader. That's our Tomcat system. So let's carry on up. And well, this line looks interesting. We've got some retained heap of 7.7 megabytes, and it's in a class called com.virtualprogrammers.services.uuid generator. And in fact, the next line up tells us there's an array list within that class, and it's in the array list that all these objects are being retained. So this looks like a classic example of a memory leak. It looks like we've got an array list that is containing far too many objects. It probably should not be holding all these objects. So we're going to look at the code in a moment and work out what's gone wrong. But here I think we've got a good example of where we've been able to use the heap dump to identify where's the problem in our application. So let's go into the code and look for this class. So that is in the services package, and it was called UUID generator. I'm going to maximize this window. It's quite a short class, as you can see. We've got a local array list, and that's called used UUIDs. And actually, Richard, who wrote this example for us, has put a little message in here to tell us this is a bad implementation. What's actually going on here is that each time we add a tutor, our application is giving the tutor a completely unique ID. And the person who wrote this, who wasn't a very good Java programmer, decided it would be a good idea to store all of those unique IDs in an array list so that each time a unique ID is generated, we can check that it hasn't already been used. Now, the unique ID is being generated by this random UUID method. I'll leave you to read the Java docs for that method, but that should give us a completely unique ID every time. I suppose there is a risk of getting 2 IDs the same, but it is a really, really small risk. So we really don't need to do this check to see if the unique ID has already been allocated. So I think the fix to this is actually that we don't need an array list. We don't need to be looking for these unique IDs. We can just return a unique ID when this method is called. So I'm going to fix this by removing the array list, and I'm just going to return uuid.randomuuid from this method. So we'll cut that out, remove all of the content of this method, and instead we're going to return uuid.randomuuid. I think I need to call to string on that because we're returning it as a string. Okay, I'm going to save that. We will need to redeploy this to Tomcat because we've made a change, so let's do that. We'll right-click again on Build XML, and we're clicking on Run as Ant Build. We'll let that deploy. Okay, that's finished. I'd like to just check I haven't broken my application, so I think we'll try it manually first of all. So here's the Add New Tutor page, and we'll add in again Matt and 50,000. We'll click on Add the Tutor. Great, so we've still got a UUID returned. We've not broken anything. Let's, I guess, then load test this to check that we fixed the problem that we saw. So we'll, first of all, I think, go into the VisualVM and reconnect to Tomcat. So we'll do that here. And go onto the Visual GC. Well, we can see that because we didn't start and stop Tomcat, the old generation hasn't been cleared down. Now, unfortunately, that's one of the things that Java does. What we need to do is, rather than just redeploy, we really need to restart Tomcat. So let's go and do that. We'll stop the Tomcat application running. I can just click on this little close button to close the Tomcat window. And we'll restart Tomcat from its folder by calling it startup.bat file on Windows or running startup.sh on Linux or a Mac. So Tomcat's now started. We've already deployed to Tomcat, so we don't need to redeploy. Let's go to our VisualVM and we'll reconnect to it. Okay, well that looks better. We've got plenty of free space in the old generation. We'll check our application's still working. There we are, our Add New Tutor page has come up. I'm not going to bother adding another tutor. The fact the page has come up tells me it's okay, so I think it's time to run the load test again. So we'll go back into JMeter, and we'll start our load test running again, and we'll go then straight into the VisualVM to see what's happening. Well, our old space has grown again. I think we need to leave this one running to see what happens when there's a garbage collection, so we'll give it a moment to get full. And in fact, I left this application running for a little while and then came back to it just to see how it was performing. And I think this now looks okay. I think it looks like we fixed the memory leak. What's happening here is that the old generation is filling up, but then a garbage collection happens and it's freeing up enough space to continue. You might be worried that we're still using up a lot of memory. Actually, because we've got 200 concurrent users all hitting our server, each of those users has to have a thread allocated to them, and that's taking up a lot of the memory. We can't avoid that, and it's not really a problem because it isn't growing in an unbounded fashion. If we go back to the monitor tab, we can see that the maximum amount of memory, okay, there's the odd little peak there, but generally this is reasonably stable over time. It's certainly not growing and growing. Once the 200 users go away, eventually Tomcat will destroy the threads and we'd see the old generation drop right back down again. Unfortunately, I can't demonstrate that in the video as Tomcat uses some complex thread pools. Importantly, this memory space at the top, this area here, is the memory that we were previously losing in the leak. This time we're not losing that memory. Every time there's a garbage collection, we can see we get it back and it becomes available to us. So in fact, there appears to be a reasonably healthy amount of memory left in the old generation. If we go back to the Visual GC tab, we can see that every time there's a GC, we get a decent amount of memory freed up. The thing to look out for is if the old generation is going up and up with no sign of it ever going back down again, that would indicate a memory leak. Of course, we're running with quite a small heap size here, it's only 64 megabytes, so if we can support 200 users with 64 megabytes, that also tells us that this application is performing quite reasonably. In production, we'd probably want to give a bigger heap size for the application to give us some more headroom, but I'm now confident that we haven't got a soft memory leak. So that pretty much covers most of what I wanted to say about memory, and in this chapter we've had the opportunity to put the knowledge to practical use, finding a memory leak in a Tomcat project, and then stressing the application by using JMeter to load test, simulating lots of users all hitting the website at the same time. I think the combination of JMeter and the VisualVM and memory analysis tools gives us a great toolset for ensuring that our applications don't have memory leaks and can perform reliably in the production environment. Coming up in the next chapter, I'm going to talk about weak and soft references. This is the final chapter on how memory works, and it's quite an advanced point, but it's not particularly complicated, and it does just complete the story on how memory works in Java.